In Java, our most basic data structure is the array, which allows us to store sequences of like-typed information and access them through a single location in memory. Sometimes, however, arrays are unwieldy, and we want to use more strongly organized data structures so that they can be easier for humans to understand and write programs around. Oftentimes, what's appropriate here is a multidimensional array. Multidimensional array is a pretty scary sounding name, but in fact the concept behind them is very basic. The idea is, what happens if we create an array of arrays? The line of code at the top of this screen shows the syntax to do just that. This line of code will create a two-dimensional multidimensional array. You'll see it's very like the syntax for simply creating an array of characters under normal circumstances. But in every instance where we reference the array nature of the variable, Java is now going to need two pieces of information. This line of code will tell Java to create 3 arrays, each of which has enough space to store 7 characters, or 3 arrays of length 7. To cement our understanding of this concept, let's write a Java program that utilizes two-dimensional arrays. While we can use multi-dimensional arrays to store information in abstract manners, it will probably be easiest for us to learn them by representing an actual two-dimensional object with our two-dimensional array. In this case, the chessboard. The classical chessboard is divided into black and white squares. It's 8 squares in width and 8 squares in height. And the program we're about to write will store in Java a virtual board with the squares correctly labeled black and white. And then at the end, we'll have it print this board out to us so that we can see we wrote our program correctly. Let's begin by simply declaring and initializing the array we're going to be using. We'll use an array of characters for this task, giving the white squares the character value of capital W and the black squares the character value of capital B. Since a chessboard is an 8x8 grid, we're going to want to declare a two-dimensional array of 8 arrays, each of which contains 8 characters. Now, in order to assign our squares their proper values, we're going to need to loop through this array to get to each individual node and give it the value we want it to have. For loops and arrays get along great because arrays always know how long they are. But a single for loop doesn't allow us to meaningfully loop through our two-dimensional array. A for loop really just goes in one direction, and our two-dimensional arrays have 2. To solve this, we're going to make use of nested for loops, or a for loop within a for loop. Our outer for loop will loop through each array in turn, while our inner for loop's job will be to loop through the nodes that those arrays contain. Common practice when creating for loops is to use an integer variable I for your initial for loop, and then j, k, and so on for subsequent for loops. However, because we're creating a chessboard, which is an actual object, I'm going to choose the value y for our outer loop, because what this loop is doing is iterating down the y-axis of our chessboard. As I mentioned, for loops and arrays get along great because arrays know how long they are. We could simply state that we would like this loop to run 8 times, which is the result of this statement here. But that's not good dynamic programming. Because if someone was to go along and change the size of our chessboard, our program would now break. And we can write this loop such that it will work for a chessboard of any size. To do this, rather than explicitly saying our loop here should run 8 times, we should have it start by asking our array how long it is. To ask an array their length, we go array.length, and that returns an integer value. This is a 2-dimensional array, so simply calling the name of the array and then .length will get us the length of the array's outermost segment. In this case, we're asking our 2-dimensional array, how many arrays do you contain? To finish off this for loop, we simply need to increment y after it runs each time. Now, let's do something similar for our inner loop. Because this loop will be iterating through the individual elements of our rows, x for the x-axis seems an appropriate variable name to use. Because our array is currently the same length in both its segments, an 8x8 array, this statement would work for now, simply going board.length again. But once again, it's not good dynamic programming. If someone was to go through and change the size of our board to be an 8x10, this program would no longer execute properly. Instead, at the beginning of this for loop's execution, let's ask the array that we've currently accessed through the outer loop how long it individually is. This once again makes our program robust and allows us to accommodate multiple sizes for our board. On that note, let's make things even more difficult for someone inadvertently to break by storing the dimensions of our board in a separate location. We'll simply create a variable called boardDim for board dimensions, assign it the value 8, and then reference it when we create our arrays. Arrays are perfectly happy using an integer in a variable to initialize themselves, letting us create dynamically linked arrays if our program calls for it. Now, if someone wants to go to this program and scale up our chessboard, they need only to change this value here. Okay, the next step in our program is to assign character values to each node in our array. Capital B for black squares and capital W for white squares. Let's start off by writing the code if we wanted to make all of the squares white. Our double for loop will pass through each node in our 2-dimensional array when it executes. So, this code in our inner for loop, each time we execute it, we're executing it in terms of one of those single 2-dimensional array nodes. To get that node, we're going to need to ask our board array what is located at row Y, column X, and then we'll change the value of that node. The thing is, each time this inner loop executes, we're going to want a different value for the nodes so that we get a chessboard that is alternating white and black squares. To help us do this, let's add another variable to our program. It'll be a Boolean variable, and we'll just call it isWhite. If isWhite is true, then the next square we add will be white. If isWhite is false, the square will be black. To code that out, let's use some if statements. If isWhite, then we put a W in our square. If is white is false, we'd like to put a B in the square for black. To check if something is not true, we can invert any Boolean value with an exclamation point beforehand. This will work for Booleans or even conditional statements. Now, we simply need to flip the value of is white. Well, using our knowledge of the exclamation point operator, which flips the value of a Boolean, we can flip the value of is white from true to false or false to true by simply setting its value to the knotted version of itself. Unfortunately, this program is not quite perfect. It turns out that if you do this, your chessboard is going to have every single row starting with a white square, while a real chessboard alternates, with every other row starting with a different colored square. Fortunately, this loop here runs once for each row of the chessboard. So, if we were to simply add an extra flip to our is white Boolean value at the start of every row, we would get alternating row starts as well. If we do it like this, we need to start is white off being false because it's going to be immediately changed to true when this loop executes for the first time. If you've followed along with that, let's go ahead and write the final bit of our program, a line of code to print out our chessboard to the screen. Actually, we're going to need a bit more than a line of code. We can use the print line function along with arrays.toString to print the contents of a single array to the screen. But this technique won't work so well with a two-dimensional or more dimensional array. So we're going to need to use a for loop again, just like this one here, to grab each array in turn and then print them to the screen. This works pretty well because print line will automatically carriage return or give us a new line in between each row we print. Here, let's use the conventional syntax variable I to iterate through our for loop. You'll notice that Java does not yet understand this arrays keyword. That's because arrays lives in the java.lang package. It can be kind of annoying when we call a function or a class and Java doesn't immediately know where to find it, and we have to go online and Google to locate it. If we're working in an IDE like NetBeans here, sometimes there's a shortcut to find common packages. In this case, if we right-click on the problem statement and ask NetBeans to fix imports, NetBeans will go through the common packages and see if it can figure out what we're doing. In this case, NetBeans has located the arrays class and added the import for us. Now, because we don't want to attempt to print out the contents of the two-dimensional array each time our for loop executes, which wouldn't work very well anyway, we're going to tell our print line statement to print out the contents of board I, or the individual array within our two-dimensional array that we've accessed here. Now, let's see if we got everything right the first time through and run our program. Wow, it looks like we did. There's an alternating white and black representation of a chessboard that begins with a white square and has rows starting in the proper manner. This might not look like much now, but its significance is pretty big. We've essentially taught our program how a chessboard looks and is. This is the first step to us creating something much bigger, like a program that plays chess. Were we to create a program that plays chess, which is a little out of the scope of this video here, but we can talk about it some conceptually, we would probably want our individual squares to be able to store more information than just what color they were. For example, we would probably want them to know what piece was on them. To make this happen, we could utilize a three-dimensional array. We could create an array that looks like this so that each square could store an array that holds two pieces of information, one character for its color and another character to represent what piece it's on. So that's the basics of multidimensional arrays in Java. Thanks for watching.